These are exponential functions. The parent function is y equals, and these are all the shifts. I gotta do this in a different spot because there's a dead spot there. A times b to the x minus h power plus v. Or what's being called the vertex here on this worksheet is hv. That's the vertex. As far as a vertex of an exponential function, I've never heard of it. Talked to many different people. They've never heard of it. I've looked it up in places, never saw it. I'm like that circus master in Dr. Dolittle when he saw the push me pull you. I've never seen anything like it in my life. But this is how you calculate it. Bx minus hv. Hv is the vertex. So domain is always negative infinity. Infinity range is the asymptote to infinity. If this a is negative, then the range is going to be to negative infinity. If the a is positive and the v is negative, then it will have an x-intercept. If the a is negative and the v is positive, it will have an x-intercept. If b is less than 1, like 1/2 raised to some power, then it's going to be reflected across the y-axis. If a is negative, it's reflected across the x-axis. So this 1/2 x is not a stretch. Y equals 1/2 x is not a stretch. It's a reflection. It's a y-axis reflection. To stretch it, I'd have to multiply it by some number. If a is bigger than 1, it's a vertical stretch. If a is less than 1, between 0 and 1, it's a vertical compression. And again, if it's negative, it flips the whole thing over the x-axis. It's an x-axis reflection. So if I put 2 to the 1/2, 2 times 1/2 to the x power, I make that my equation. That would be a stretch, a vertical stretch of 2. I'm going to draw it in. The vertex here would still be h, which is 0, and k, which is 0. The vertex is still 0, 0. The asymptote is still y equals 0 because k is 0. The x-intercept doesn't exist because it's got that y-asymptote, or y equals 0 is a horizontal asymptote. Y-intercept is when x is 0. And when x is 0, 1/2 to the 0 power is 1. 2 times 1 is 2. So 0, 2 is the y-intercept. And then I can domain and range. Domain is negative infinity to infinity, as always. The range, this is a right side up. A is positive. If a is positive, it's a right side up. The range goes to infinity, and it starts from the asymptote, so 0 to infinity, and that parenthesis has to be curved at 0. Now I can plot some points. I already know when y is 0, x is 2. I'll do 1, 2, and negative 1, negative 2. Let me try 1. I'm using this function. When x is 1, 1/2 to the 1 is 1/2. 2 times 1/2 is 1. So at 1, it's 1. So this is stretch. It's been pulled up. When it's 2, 1/2 squared is 1/4. 2 times 1/4 is 1/2. So that's 1/2. At 2, it's 1/2. It's pulled up a little bit. That's as far as I'll go on that side. I'll do negative 1. 1/2 to the negative 1 is like 2 to the 1, which is 2. 2 times 2 is 4. So negative 1 is 4. See this? On this side, you can really see the stretch. And then negative 2, 1/2 to the negative 2 is like 2 squared. 4, 2 times 4 is 8. So 4, 5, 6, 7, 8. So it's like that. So now I can really see that stretch. Now I can draw this graph in. And so it's stretched it. It's done a vertical stretch. I'll keep calculating the vertex. I don't know what it gives us, and I'll just keep calculating it. So that's actually a stretch or compression, is when this a has a value. It's bigger than 1. Between 0 and 1, it would be a vertical compression. Bigger than 1, it would be a vertical stretch. And again, if it's negative, then it's reflected on the x-axis. So those are the reflections. The reflections are where this 1/2 to the x power is actually a reflection, a y reflection. And if that a is negative, in other words, y equals negative 2x, negative 2 to the x, which is really, the 2 is raised to the power and then it's multiplied by negative 1. That would be an x-axis reflection. So that one would look like that. You know, where the parent function looks like this, that reflects it on the x-axis. So okay, that stuff is out of the way. Now I can go to the actual questions, and let's see what I have here. Hold on one second. I've got to check something. All right, sorry for that delay. Let me look at 2 to the x minus 1. Well, h is 1, and v is 0. So the vertex, what's being called the vertex, is at 1, 0. That one's fine. I need the domain. The domain is negative infinity to infinity. The range, well, what's the asymptote? Y equals 0. There's no v, so y is 0. So the range is 0 to infinity. And the a, remember, it's y equals a b to the x minus h plus v. There's a dead spot on my screen. Okay, plus v. And so if v is 0, then the range is just the asymptote is 0, and the range is 0 to infinity. And I need the x-intercept. Well, if there's a asymptote at y equals 0, and this is right side up, the a is not negative, then there is no x-intercept, none. The y-intercept is when x is 0. It's going to be 0 something. Well, if x is 0, 0 minus 1 is minus 1. 2 to the minus 1 power is like 1 over 2 to the first power, 1/2. So 0, 1/2 is the y-intercept. I guess I'll draw on this quote-unquote vertex, 1, 0. And then I can do some points. What point shall I do? I've already done 0, 1/2. I'll do 1, 2, and negative 1. I can do negative 2, I guess. I'll just draw it down here, and that'll be enough. When x is 1, 1 minus 1 is 0. 2 to the 0 is 1. So at 1, it's 1. At 2, 2 minus 1 is 1. 2 to the 1 is 2. So at 2, it's 2. I guess I have to do maybe 3. 3 minus 1 is 2. 2 squared is 4. At 3, it's 4, and so forth. It's going to keep going up, bigger and bigger. And then I'll do minus 1. 2 to the minus 1 minus 1 is 2 to the minus 2. 1 over 2 squared is 1/4. Yeah, that's all I'm going to do, because I can't draw it any closer to that asymptote than 1/4. It's going to just be impossible. So there's the asymptote at y equals 0. That should be on the line. And then this is negative 2. Was it negative 1 that was 1/4? Yeah, negative 1 was 1/4. And so now I've really got enough to draw this thing. Whoops. It looks something like that. That's it. Let me do the next one. Again, the vertex is at h, which is negative 1, because it's x minus h. X minus negative 1 is x plus 1. And v is 0. Domain, negative infinity to infinity. Since v is 0, the asymptote is y equals 0, and the range is 0 to infinity, because it's not, again, this a part is positive. If this a is positive, then it goes to infinity. If a is negative, then it flips it over the x-axis. What else do I need? The x-intercept. Well, this one doesn't have one because it's right side up. And it's y equals 0 is the asymptote, so I'll nope out of there. Nope out of an x-intercept. And I guess I'll draw on this vertex, whatever this is supposed to be, -1, 0. Right there. Y-intercept. Symmetry. Again, none of these have any symmetry. Y-intercept is when x is 0. 0 plus 1 is 1. 2 to the 1 is 2. So y-intercept is 0, 2. And then I can do some points. I did 0, 2. I'll do -1, -2, 1, 2. At 1, 1 plus 1 is 2. 2 squared is 4. At 2, 2 plus 1 is 3. 2 to the third is 8. So at 1 it should be at 4. And at 2 it should be 8. And then at -1, -1 plus 1 is 0. 2 to the 0 is 1. -2 plus 1 is -1. 2 to the -1 is 1/2. So at -2, it's 1/2. Oh, nice. And at -1, it's 1. I've got enough to draw the graph. This should be getting closer and closer without ever touching. Make sure, put the arrows there at the ends to show it just keeps going and going. So there's that one. Here's another one. Still haven't, remember again, if a is positive in this general form, a times b to the x minus h plus v. If a is positive and v is negative, then it will have an x-intercept. If a is negative and v is positive, it will have an x-intercept. The negative is not part of what's being raised to the exponent. The negative, it's like -3 times 2 to the x power. It means -3 times 2 to the x. If the number inside, if the number being raised to the exponent is negative, it's not an exponential equation. Okay, here is the next one. 2 to the x plus 1. Well, h is 0, so 0, and k is 1. So hk, 0, 1. The asymptote is y equals 1 because of that k. K gives the asymptote. So y is 1. I might as well draw this in 0, 1 is the vertex. Domain, -infinity to infinity, always. The range, since the asymptote is 1, it's 1, and it's right side up. It's 1 to infinity. And x-intercept, what have I told us? What have I told you? If the v is 1 and this is just positive, the a in this general form, a times b to the x minus h plus v is a positive number, there is no x-intercept, none. And the y-intercept is when x is 0. Two to the 0 is 1 plus 1 is 2. So 0, 2. And I guess I'll put that in the graph. Then I can graph some points. I already know 0, 2. And I'll do 1, 2, 3, -1, -2. So let me try -1 first. 2 to the -1 is 1 over 2 to the 1 is 1/2 plus 1 is 1.5. And -1, 2 to the -1 is like, it's not 1.5. I'm putting -2 in. 2 to the -2 is 1 over 2 squared is 1/4. 1 plus 1/4 is a negative. Oh, did I do -1 first or -2 first? It doesn't matter. I'm going to do -1 first. 2 to the -1 is 1 over 2 to the first is 1/2. Plus 1 is 1 1/2. So this should be 1.5. And then at negative 2, 2 to the negative 2 is 1 over 2 squared. 1/4 plus 1 is 1 1/4. 1.25. So in other words, it's getting closer and closer to the asymptote of y equals 1. And then at 1, 2 to the first is 2 plus 1 is 3. 2 to the second is 4 plus 1 is 5. 2 to the third is 8 plus 1 is 9. So 3, 5, and 9. 3, 5, 9. That's enough to draw it. Make sure to put those little arrows. And I think that's it. Symmetry, it doesn't have any symmetry. Exponential functions do not have symmetry. Okay, there's that one. Now this last one I think is going to have an x-intercept. Because yes, the a, in this general form, a times b to the x minus h plus v, the b is positive. There's no negative number multiplied. But the v is negative. So when, I'm sorry, a is positive and the v is negative. So when a is positive and v is negative, it's going to have an x-intercept. Let me find the vertex, hk. Well, h is 0, k is minus 2, so 0, minus 2. Domain, always negative infinity, infinity. Range, well, the asymptote is y equals k, so y equals minus 2. So the range is going to be minus 2, and since a is positive, it goes up to infinity. X-intercept, y-intercept. The y-intercept is when x is 0. When x is 0, 2 to the 0 is 1. Minus 2 is minus 1. 0 minus 1. So I'll put it in here. 0 minus 1. I'll graph it while I'm at it too. 0 minus 1. And 0 minus 2 is this vertex. Okay, that should be that's on the graph. It should be filled in. And then the x-intercept is when y is 0. So this is 0 equals 2 to the x minus 2. Add 2 to both sides. 2 equals 2 to the x. I could do whatever. I could take the log of 2 or the natural log of 2. I'm going to take the natural log of both sides. Natural log of 2 equals natural log of 2 to the x power. When I have an exponent with a log, I can put the exponent in front of it. X times log of 2. And I divide both sides by log of 2. X equals log of 2 over log of 2 equals 1. So when y is 0, x is 1. So x is 1 when y is 0. That's the x-intercept. 1, 0. So I'll put that 1, 0. The asymptote is at negative 2. And then what other points will I do? I'll do 2. I'll do negative 1, negative 2. Maybe that's going to be enough. Negative 2. 2 to the negative 2 is 1 over 2 squared is 1/4 minus 2 is negative 1.75. Excuse me. And then negative 1, 2 to the negative 1 is 1 over 2 to the first, which 1/2 minus 2 is minus 1.5. I might as well draw those in. At negative 1, it's minus 1.5. At negative 2, it's minus 1.25. And then at 1 is 0. At 2, 2 squared is 4, minus 2 is 2. At 2, it's at 2. And then maybe I'll do one more at 3. 2 cubed is 8, minus 2 is 6. So at 3, it's at 6. And that should be enough for me to graph this thing. And see, so that one, since in this general form, y equals a times b to the x minus h plus v. If a is negative and v is positive, it's got an x-intercept and it's flipped over the x-axis. It's a mirror image. Goes down. If A is negative and V is, if A is positive and V is negative, then it's got an x-intercept. And that's what this one is. It's got a positive A, it's just 1, and the V is negative 2, so it's got an x-intercept. And I was able to find that. I don't know why I put those so close together. X-intercept, I don't know why I originally did that. 1, 0, and y-intercept is 0, minus 1. There's a few exponential equations and some explanation of how to graph them.